All right, record is on now. So we have finished the basic stuff. That is, we have converted the displacement into the influence side of RB. We choose RB simply because, you know, the information right here is given for RB. So we choose RB. Okay, you need to know what you can do with the information. Okay, and once we choose to do with the RB, we have RB. So once we have unlocked RB, we can use that information and calculate RA by using the simple equilibrium equation sigma mc equal to 0. And once we've done that, now you know two reactions, we can simply use sigma fy equal to 0. Okay, so now in fact we have two design functions left. The first one is the shear at D. So we're gonna do VD. Okay, so the let's go. Okay, when you can have VD, you can have VD when you cut the free body diagram at D, correct? So I'm gonna show you the free body diagram when I cut it at D. Okay, so when I cut the free body diagram at D, I will have this, right? I will have RA, I will have RB, and then I will have VD. And I will have two cases of the free body diagram. The first is when, because we move the unit load around, remember? So the first free body diagram will be this, plus the unit load somewhere on this body. And now that we are at VD, let me incorporate MD in there as well, because MD will also show up here. Okay, that's MD. Okay, that's the first free body diagram. And then the second free body diagram will be the one that, you know, it's the same, but this time you see RA, oops, sorry. RA is here. RB is there. We cut it here. VD is also there. MD is there. But this time, because the moving load is moving, it is somewhere outside here. It's between D and C. Can you see the difference? So based on the first free body diagram, basically I can say it's a free body diagram that includes the unit load. And the second one, I don't need to do that, right? The second one is the free body diagram that excludes the unit load. So you can see from this free body diagram, the one here, I can say my VD is equal to RA plus RB minus 1. But this valid only when my X is larger than 0 but does not exceed 6. That's where D is, right? X equal to 6. And then the second free body diagram, this is when the unit load moves away from the zone. So my VD now is simply equal to RA plus RB. right? And this one is valid when x is, say, from 6 to 9. And I can do the same for the moment. MD here from the first free body diagram is gonna be equal to RA. I'm taking the moment at D, of course. RA multiplied by 6 plus RB multiplied by 3 minus the load multiplied by 6 minus x. Okay, and the range is the same. The second one, MD becomes just RA multiplied by 6 plus RB multiplied by 3. And the range is again the same. Okay, see, once you have solved one reaction, the rest is just playing around with your equilibrium. Okay, so just to finish the job, let me give you the okay, try my best to draw the influence line here. 1 minute. That is going to be, let's hope that you know, okay, we can cooperate everything. That's where C is, that's where A is, that's where B is. Okay, so the influence line of that's D, okay, of VD, you know, by using these two equations will be like this. Okay, that one is this equation. Let me try to give you some color so that you know you can see the difference. Okay, this one is that. Okay, and now let me try to replace this as well. Okay, and then the next one, you know, is this one. Okay, and right here you just need the line to connect them. The value jumps. Okay, and right here is 0.006. Right there is right here minus 0.098. Right here is minus 0.393. Here is 0.607. Right here, this point is 0.307. Okay. And the last one is bending moment. Okay. This is the influence line of, oh my God. Oh, let's hope that we can go back. Okay, we are back in business. the last one is for moment, okay? And it's gonna look like this. Okay. That's MD. Yes, you know, you should know that this point is 0 and that point is 0 because it's a support. So this is 0 and that's 0 as well. And maybe I should do the same here by using the green color to indicate that this is from this. And then the orange, this is from that, okay? And right here is point minus 0.018. Here is 0.312. Right here is 1.182. And here is 0.582. Okay, so that's the end of the first problem. So let me give you another example because we you know, right now I have to say that a computer program can generate the influence line of the structure in like no time. So I don't wish to push the issue beyond the 1 degree of redundancy. Okay, so that would leave us another interesting case, that is this case, the prop cantilever. Okay, so let's say I am.
Teacher, can you go back again?
Yes. Hello? I heard something. You want me to go back to the previous page?
Yeah, yeah.
Okay. There it is.
Down more, please, teacher.
Hmm?
I can't see the blank.
Okay. You're gonna have to speak up, folks. I never cue you because you speak something related to the class, right? In fact, I never cue anyone.
Thank you, teacher. I already finished.
Okay. Let's wait for a minute or so, okay? Let's make sure that you guys are done. Okay. Now, let's say if the information like this is given to you. Okay. This is straight line. Okay. And now we have the displacement here at displacement at 1 equal to minus 6.1875 over EI. Displacement at B, it's my B, is equal to minus 22.5 over EI. I should say that this is based on something like this. Okay. Now the next one, displacement at 2, that's 2. Displacement at 2 is equal to minus 45 let's be crazy, 56.25. You guys like that, right? Over EI. Delta C is equal to minus 72 over EI. And then delta D is equal to minus, correct? 99 over EI. So when you see if this information is given to you, you must know how to turn this information into, one set of information about the influence line. If you are given like this, you must notice that this is the displacement caused by the load here. And the load here is related to the reaction at C, right? It doesn't relate to anything else. It's just the exact opposite of RC. So you guys should know right away that you should use this information to turn into the influence line of RC, right? Notice that this load is where C is, but it's in the opposite direction. So it has to be used to calculate RC, right? It's pretty simple. Am I right? So in fact, we can simply say RC. It's going to be equal to, hang on a minute, I have problem with this, minus delta CX divided by delta CC, right? And all of these numbers are delta CX. Correct? So without further ado, I can just go ahead and turn this into the influence line of RC. Right? Remember that it has to go the opposite way as well. And you guys must notice one thing, that the unit load is right here at C. The unit load is at C, so the portion CD has no load. So if you want to really become a true engineer, you must know that this portion is straight. Because there's no load, it must remain straight. The portion that is influenced by the unit load 1 is from the support to the location of the load itself. This has to be a curve. But after that, there's no load. Just like you bend the ruler, and this is the portion that you don't bend. It's after the portion that you apply your load. So it must remain straight. Okay, so RC is going to look like a curve up until C, and then this portion will become a straight line. At location number 1, right here, you get the value from point. This one is going to be 6.1875 divided by what?
Teacher, I can. Oh, okay. Thank you.
All right. You're too fast. Okay. So it is 6.1875 divided by something related to C. That is this one. So over 72. You move on to B. Right there, the number will be 22.5 divided by 72. Right there, it is going to be 45.56 divided by 72. And at C itself, that's 72 over 72. And right here, that would be 99 over 72. It is greater than 1 now. So, okay, the final number, that would be 0.086, 0.3125, excuse me, there's no room. So this one is 0.633. That is 1, of course. And this one is 1.375. Okay, and like the first one, once you have solved one reaction, this structure becomes a determinate structure, and you can simply solve what comes next in your way, which is the moment at B, at A, I'm sorry. Moment at A. Why my M is always like that? Let me try again. Okay. MA. So my MA, by taking moment at A, we should get RC multiplied by 6 minus the unit load at any X location, right? Let me try to incorporate the picture of the beam into your vision. Okay, MA is there. Once you know RC is this one. Okay, RC and the unit load is somewhere. And our X begins from here, so that one is multiplied by X. Okay, when we take moment at A, so it becomes, when you take moment at A, you have RC multiplied by 6 minus unit load multiplied by X. And again, because you now know all the value of RC, you should be able to come up with the MA very easily. Okay. So let me, I don't know if it's a good idea, but let me try to write in red. But be careful, this is the influence line. So from this equation, when it is 0, RC is 0, right? Right there. And X is 0, so MA is 0, which is natural because when your unit load is at the support, you know, when your unit load is right here at the support, how can you have moment? It's going to keep increasing once the load moves away from the support, right? And it becomes 0 again when the load reaches RC. So the shape of the influence line naturally will look like this. That one should be a straight line. Okay, and this value is minus 0.984. This one is minus 1.125. This one is minus 0.702. That is 0, of course, and the last point is 0.75. Oh, geez. Okay. Okay, and the last reaction that we need to obtain is RA. But again, RA is simple enough because you have moment. So once you have this, oh, I can't believe I ran out of space. So let me move on to the next page. Okay. Do you need to do something here? Maybe. Okay, let's wait for a minute. Okay, you guys done?
Yes.
Teacher.
Okay.
Teacher.
Yes.
The line at from the 0 to 0.75 is linear, right?
Yes, this is also a straight line. Good.
Okay.
Be straight line. Okay, let's move on. Next page. For this, now RA is very simple. RA is now equal to 1 minus RC, right? Simple as that. So you're gonna have RA that looks like, maybe I should enlarge this a little bit. Oh, not like that. I can't do anything with the picture anymore. Clumsy. Anyway, here we go. And the influence line of RC should look like, let me try that. Okay, it's very simple. You just take 1 and then minus RC. Okay, so I don't even have to do this, you know. But anyway, this is 1. So at this location, it becomes minus 0.914. At B, it is 0.6875. At location 2, it is 0.367. And right there, it is minus 0.375. So this is the influence line of RA. Okay. And again, we have the question of the influence line of, design function at B. So I am going to do the same thing by cutting the free body diagram. And now you know that once we cut the free body diagram, I will have this free body diagram up to B, where I will have VB and I will have MB. The first free body diagram should include the unit load anywhere on it. Okay. And then the second free body diagram will be without the unit load on it. So to manage the space a little better than the last time, let me try to write the equation first this time. Okay. So here you will see that if you look at the free body diagram, VB, it just equal to RA minus 1, right? And this should be valid from 0 up to 3, where B is. And your moment equation, MB, oops, my bad. Will be equal to minus MA plus RA multiplied by 3 minus the unit load itself, 1 multiplied by 3 minus x. Okay, say, yep, this is our x. Okay, and then in comes the second free body diagram. Yeah, VB, and then MB, but this time we don't have the unit load anymore. So our VB, oops, our VB is this time, it's just simply RA, right? Wow. And this one is valid from 0, oh, I'm sorry, my bad. From 3 up until 7.5. And then my MB will be minus MA plus RA multiplied by 3, and the range is the same. Okay, this is also the same range. As simple as that. And now we can complete the let me try to, okay, give it a straight line like that. And now VB, the first portion, you guys can see that. Let me enlarge it a little bit. The first portion is gonna come out into, or let me try to find where B is first. About that. Okay. So this one comes down here as a part of that equation. And the values are minus 0.086. And in fact, you know, I should say this is equal to, because we have two values, right? And I should try to go back and fix this a little bit, because we have two values here. So yes, it should be equal here as well. Okay, my apologies. So let's go back here. Okay, now this value is minus 0.3125, and then you have the next one by this equation, and this, yes, this is a straight line again, and this one is a curve. Oops, doesn't look like much. Okay. All right. Good enough. That's straight, okay? It's a straight line. And the values are 0.6875. This is basically RA, right? 0.367, and then minus 0.375 here. To be fair, we're gonna connect that by the black line. Okay, this is the influence line of VB. And in the same manner, we are going to have the influence line of MB. Okay, here, oops, green first, that one. Okay, and this is 0.258. This is 0.9375, and then we have the orange. Again, that is straight from this. This is 0.4 exactly, and this is minus 0.3750. That's it, ladies and gentlemen. We have covered everything in 2 hours today. So I'm gonna have this chair for a little while so that you guys can catch up. You know, generally I would have time to give only one example in the classroom. So this is the upside of the online classroom. That is, you have in fact more examples in not only the influence line, but in moment distribution and sometimes before that as well. But unfortunately, it seems like not all of you can adapt to the new requirements of your life. So much appreciated for folks who can come to the classroom. Now we only have 15, okay? Less than a quarter of the class. So let's hope that all of you who are here can understand everything I have to say. And when you have the opportunity to go back and revisit the videos, it should help you understand things better. Okay. So is there any question?
Teacher, go down, please.
I cannot go down any further. That's the end of it, ma'am. That's the end of it. So it's something that you're not sure about, because I don't write anything below that. Is there anything that is not clear to you? Now, mind you, these numbers can be off, you know, because the way that my handwriting is on my notes, so and so, and this has been done some time, but most if not all of them are correct. So, but you have to, you know, be reasonable that sometimes if you find that the numbers are not in good agreement with your understanding, I may be wrong. Okay. Can I stop the share? I can actually stop the video first, right?